Right. So, question 11 now of 2018 paper. Now, the reaction between sulfur oxide, dioxide, and oxygen is given right over here. You guys can see this reaction. You must have identified that it's an exothermic reaction. This is actually an example. This is actually the contact process, which is a part of our syllabus, right? This is actually the most important reaction of the contact process, which includes vanadium pentoxide as the catalyst. Now, temperature and pressure conditions would favor the reverse reaction. Now, remember one thing. If the forward reaction is exo, the reverse has to be endo. Okay? Endothermic. And endo are favored by high temperatures. What about the pressure? So if you look at the pressure side, 2 moles of gas on right side, 3 moles of gas on the left side. 3 moles because you've got 2 moles of sulfur dioxide, 1 mole of oxygen, so 3 moles in total. So from 2 to 3. So you're going in the reverse order. If you're going in the reverse order, you're going from fewer moles to greater moles. You would need a lesser pressure. Okay, lesser pressure would actually, what it would do is lesser pressure moves the equilibrium to the greater mole side because equilibrium wants to regain the pressure, right? So in order to regain the pressure, it's going to increase the number of molecules that are in there in the equilibrium by shifting it to the left hand side because left hand side has greater moles. So all we need to do is to lower the pressure, then the equilibrium will shift it to the left hand side. If it shifts to the left hand side, the reverse reaction is automatically favored. So pressure has to be low. Option C is the correct answer. Temperature high, pressure low, only then will the reverse reaction be favored. Now, this is a very typical question, although it's not asked about the reverse reaction. Usually, you're asked about the forward reaction. And so, if this would have been a forward reaction, then the conditions would have been different, by the way. Now, which statement about the effect of catalyst on the reversible reaction is correct? Now, remember one thing, catalyst has no impact, no effect on the position of the equilibrium. Okay? Position doesn't change. Catalyst, it favors both the forward as well as the backward reactions equally and simultaneously, because of which the equilibrium reaches dynamic status at a faster speed. Okay, so now activation energy of forward stays the same. No, it does not stay the same. It reduces. Both forward as well as backward reduces. Composition of equilibrium mixture stays the same. Well, yeah, that might be to some extent fine, but the composition keeps changing, right? If the rates change, composition have to change. Rate of the backward state, no, it does not stay the same. Value of the equilibrium constant changes. Equilibrium constant is never affected by the catalyst. Equilibrium constant is only affected by temperature. Remember that, okay? Only temperature can change it. Can change the K, Kc or Kp. But catalyst or all of those things do not have any impact on it. So only option B is correct. Of 13. Now, which oxide is insoluble in aqueous sodium hydroxide? Aqueous sodium hydroxide is an alkali. This has to be an insoluble. So if it's an acid, it will react and it will dissolve. So this cannot be the answer. Aluminum oxide can also not be the answer because it is amphoteric. It will react with it as well. So then finally, we are only left with magnesium oxide. Magnesium oxide is a basic oxide and it will not react with a base. Therefore, it is insoluble. X, Y, and Z are three elements in the third period. X reacts with chlorine to give liquid product. Y reacts with chlorine to give a solid product. And that solid product actually dissolves in water at a pH of 7. Oh, okay, so they have actually given you the hint. pH 7 का तो हमारे पास पीरियड 3 का क्वेश्चन है ना, थर्ड पीरियड का है. तो पीरियड 3 में it's only sodium whose chloride dissolves in water to give a pH of exact 7. बाकी सबके तो chlorides के pHs values different होती हैं, right, with water. So this has to be sodium chloride. Okay, now Y has to be sodium chloride. Z की बात करें तो Z reacts with chlorine to give a solid product that dissolves in water to give a solution of pH 6. This one is acidic. X reacts with chlorine to give us liquid. Okay, now which elements are good conductors of electricity? गुड कंडक्टर्स ऑफ इलेक्ट्रिसिटी हमें देखना है, तो y हैज टू बी द करेक्ट आंसर, क्योंकि y द सोडियम, इट्स मेटल, राइट, इट्स करेक्ट, इट हैज नथिंग, सो इट्स ईदर ए बी और सी, ठीक है, डी नहीं हो सकता। व्हाट अबाउट x एंड व्हाट अबाउट z? लेट्स सी कौन से ऐसे क्लोराइड्स हैं एंड कौन से ऐसे पीएचसी के एलिमेंट्स हैं जो कि क्लोरीन के साथ रिएक्ट करके लिक्विड्स बनाते हैं। तो एक ही है जो कि लिक्विड बनाता है, और वो है सिलिकॉन टेट्राक्लोराइड। सिलिकॉन क्लोरीन के साथ, पीएच3 में से सिलिकॉन ही रिएक्ट करता है क्लोरीन के साथ, जो कि एक लिक्विड बनाता है, या फिर फास्फोरस रिएक्ट करता है PCl3। लेकिन अगर आप बात करें दोनों की, दोनों ही लिक्विड्स हैं, राइट, दोनों की अगर आप बात करें तो सिलिकॉन और फास्फोरस, इन दोनों में से तो ये तो बिल्कुल भी इलेक्ट्रिसिटी कंडक्ट नहीं करेगा। सिलिकॉन की अगर आप बात करें तो ठीक है, चलो, हाँ, कभी करता है कभी नहीं करता, क्योंकि मेटलॉइड है, राइट। व्हाट अबाउट जी? Z reacts with chlorine to give a solid product, and it dissolves a pH of approximately 6. pH 6 है ना? pH 6 किसका होता है पता है? कौन से सॉलिड का होता है? 6 के करीब करीब सबसे जो है वो है मैग्नीशियम का pH। मैग्नीशियम क्लोराइड जो होता है वो आयोनिक सॉलिड तो होता है, बट विथ सम कोवेलेंट कैरेक्टर। ओके, आयोनिक सॉलिड विथ सम कोवेलेंट कैरेक्टर। तो मतलब, and you guys know that covalent compounds actually dissolve in water. When they do that, they give you acidic products, right? The pH becomes acidic in them. Magnesium chloride has some covalent character, so this means it's when it dissolves in water, it's gonna turn the pH of water slightly acidic, approximately 6 to 6.5. So this Z has to be magnesium as well. So both of them are metals. YZ have to be combos that are good conductors. Option B is the best answer. Option A is rejected by default because silicon, okay, it's a metalloid. It may conduct electricity under certain conditions, but under other conditions, it may not. Magnesium is a far better answer to that, conducting electricity. Okay? And then last 15. A solution contains both magnesium and strontium ions at the same concentration. The solution is divided into two equal portions. Aqueous sodium hydroxide is added dropwise to both of them. Okay. Now, dilute sulfuric acid is added dropwise to the other portion now. Okay. Then, which choice correct? Strontium hydroxide and magnesium hydroxide. Now, we are comparing the hydroxides of group 2 and the sulfates of group 2. So, if you guys remember the trends, you can answer this question. Now, the solubility of hydroxides increases as we go down the group. Okay, group 2. And what about sulfates? So solubility of sulfates decreases as we go down the group. So barium sulfate is actually a white precipitate, right? Because the solubility is reducing. Solubility reduces as we go down the group. So this means strontium, which is right here in group 2, strontium sulfate here and strontium hydroxide here. Strontium hydroxide is going to be more soluble than magnesium hydroxide, so it's going to give you a clear solution. So with sodium hydroxide, strontium hydroxide will not give you the precipitate, okay? It's magnesium hydroxide that will. The precipitate, I just want to see the precipitate, so yes, it's magnesium hydroxide. What about sulfuric acid? So with sulfuric acid, it's going to be strontium sulfate because it's strontium that is insoluble in water, right?